In this video, we're going to see how one can use Oscar Sketch to draw out a mechanism using an aromatic ring. Start with a very simple reaction, the reaction of benzene with bromine. Well, this is a simple reaction. Why is it so simple? Well, it doesn't work. What you would think is the double bond can come over here, react with this bromine, kick out the other one as an anion, and you get a reaction. Well, you can draw the arrows for this, but in reality, this doesn't work. Why doesn't it work? Because the bromine isn't acidic enough to react with this very weak double bond serving as the base. So what we have to do is we have to add another acid which makes the bromine more acidic. And the acid of choice is to use iron tribromide. So here's our iron. We add 3 bromines. And what we're going to find is that this will make the bromine much more reactive. So let me get rid of those arrows that we already had, because the first step here, it doesn't involve the benzene. It's simply that the bromine, one of the lone pairs on the terminal bromine over here, will come along and it'll attack the iron. And now we go up here and get our little Wolfie follows the arrow button. Come down here, click there, and that gives us our Lewis acid bromine complex. Now this thing, it shows you is we've got a Br plus there, but actually what we're going to do is we're going to react over here at the end. And so let's draw another arrow. Okay, let me copy the benzene. Here the benzene's copied. Okay, now what we're going to do is we're going to see that the double bond here can come and react to this bromine, and it can kick out the iron tetrabromate. And this reaction works just fine. And we get this weird looking species over here, which is an auranium cation. And the auranium cation, the important thing is to remember is where that bromine attacked, there's a hydrogen there. In fact, there's a hydrogen in both these places. Let's draw that hydrogen in, because that's the hydrogen that's going to leave. After all, this is a substitution reaction. So we only need one more arrow. This arrow just comes in here and shows that that's coming down here. He says, well, what's going to pull off that hydrogen? Well, we use the bromide. We use the iron over here. So we'll simply grab this to there and draw a final reaction arrow, and we are done. And that's the full substitution reaction.